When Orion returns from the moon and first encounters the atmosphere, the crew module will be traveling at 25,000 miles per hour, or nearly 7 miles per second. Orion skip entry will look a little like a stone skipping off of a pond. The entry itself is about 20 minutes long. The entry involves a first encounter with the atmosphere, and then we skip. We start to gain altitude again. We're able to reject some of the heat back out to space. And the second entry is slower. We've let off some speed by that point. And if we're to have a gentle landing in the Pacific Ocean, we have to dissipate all of that energy. Skip entry improves crew safety by giving us a consistent, predictable, repeatable landing target. That brings the crew closer to recovery forces, and it minimizes the time for their safe recovery. This will be the first attempt for a human-rated system to pull off a skip entry. If we look back to Apollo had a skip entry capability, and it was part of its design space. However, they did not exercise this capability in operation for lunar missions. They lacked the computational power, the simulation capability, the integrated test labs, in order to feel confident that they could pull off that maneuver safely for the crew. And so if you go back and look at the splashdown sites for the Apollo missions, you'll see that they were in a reasonably narrow longitudinal band, but they were spread all up and down the Pacific Ocean in latitude. We're able to bring on skip entry for Orion is largely through the confidence that we've gained, given decades of exponential growth in computational power, the development of integrated test labs where flight software and hardware can be in the loop. And so the analytical capability is really a joint effort between Lockheed Martin and NASA. Millions of flight dynamic simulations are performed by the team, thousands of talented and skilled engineers who have worked very hard to make the mission happen.